Hello, in this short video we are going to solve the following challenging problem on the topic of evaluating definite integrals. The following integral from 0 to 2 absolute value of x minus 1 minus x is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer to the problem. Okay, so let us now solve the problem. So this is a definite integral involving absolute value. Probably if you have enough experience of these kinds of problems, you know that first of all you have to get rid of the absolute value signs by decomposing the interval of integration into appropriate intervals in which you know the sign of the expression within the absolute values. But here we have two absolute values involved. So let us start to get rid of the one inside. Okay, so if x is greater than 1, then x minus 1 is positive, so I can just simply remove the absolute value sign, and if x is less than 1, x minus 1 is negative. I can remove the absolute value sign, but the price that I have to pay is to multiply the expression by minus sign by the definition of the absolute value. Okay, so this motivates me to decompose my interval from 0 to 1 and then plus 1 to 2. Okay? If I go from 0 to 1, it means that x is always less than 1. If x is less than 1, x minus 1 is negative. So I can remove the absolute value, but I have to multiply this expression by a minus sign. If I multiply this by a minus sign, it becomes 1 minus x. So I will have this absolute value sign outside. I have my minus x here. I have my dx here. But this becomes 1 minus x. Okay? But here, x is between 1 and 2. So it is always guaranteed that x is greater or equal to 1. So x minus 1 is positive. I can just simply remove the absolute value sign. So this becomes simply x minus 1. So I have the absolute value here, I have minus x here, dx here, and this one becomes x minus 1. Okay, so let us simplify things a little bit. So here, this integral from 0 to 1, this becomes absolute value of 1 minus 2x dx. But this x and x are gone. Minus 1, absolute value of minus 1 is just 1, so this becomes plus integral from 1 to 2 dx. Okay, this part is extremely simple. Yes, we can calculate this very simply, but here I have another absolute value involved, and what matters for me is number 1/2, because if I put 1/2 for x, this expression becomes 0. So if x is greater than 1/2, my expression becomes negative. If x is less than 1/2, my expression becomes positive. So this motivates me to break this interval into another two subintervals. One from 0 to 1/2, another one from 1/2 to 1, and then if you don't mind, let me copy and paste this last part from 1 to 2 dx. Okay, from 0 to 1/2, x is less than 1/2. If x is less than 1/2, then 1 minus 2x is positive. So this becomes simply 1 minus 2x, because when I am sure that 1 minus 2x is positive, I can simply remove the absolute value sign. But here, when x is greater than 1/2, between 1/2 and 1, 1 minus 2x is actually negative. I can remove the absolute value, but the price that I have to pay is to multiply this by minus sign. So then it becomes 2x minus 1 dx. So this means that to calculate the question mark, I have to now calculate three very simple standard definite integrals. Okay, so I need to find primitive functions. So primitive function for 1 is simply x. Primitive function for minus 2x is minus x squared. So I have to run it from 0 to 1/2 plus. Again, a primitive function for 2x is simply x squared. The primitive function for minus 1 is minus x. But this time I have to run it from 1/2 to 1. And then plus. A primitive function for this is simply x. I have to run it from 1 to 2, and then I have to calculate these numbers. Okay, so I replace x with 1/2, so this becomes 1/2 minus 1/4, minus I have to replace x with 0, which becomes 0, so I don't need to write it. Here I have to replace x with 1, which becomes 1 minus 1, which is 0, minus I have to replace x with 1/2, so it becomes 1/4 minus 1/2. Okay, so we have to be careful here. So plus minus, I simply write minus them. And then this one becomes simply 2 minus 1. And I have to calculate this. 1 over 2 minus 1 over 4 is 1 over 4. This becomes minus 1 over 4, but then it becomes plus 1 over 4. And then this one is simply 1. So this becomes 1/2 plus 1. So the answer to the problem becomes 3/2. Okay? This is an analytic way of solving the problem. Might be another alternative to solve the problem is to try to draw the graph of this function and then highlight the region enclosed between the graph of the function and the x-axis within the interval from 0 to 2, and then find the area, because the graph of this function will be consisting of just lines. So the regions that you will have are either rectangles or triangles, and all of them are very easy to determine their area. So one other possibility is to use this, but I want you also to learn the analytic way of doing things. Okay, so if we go back to the problem, so option B is the correct answer to the problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.